wanted to do the last three reactions. These reactions are pretty simple, and it brings us back to our original structure. So if you see here, so here's where we left off, the succinate right here. So your COO minus, CH2, CH2, COO minus. Now let's just look, going from this structure to over here, what do we make it? What's the difference here? You see that both of these are missing a hydrogen, and there's a double bond right there. So this is just an elimination reaction, really. We use FAD right here. It's a stronger oxidizer than NAD+. It's just more reactive. This right here isn't super reactive, so it needs this. We also, it doesn't usually talk about this, but a lot of times there's a basic amino acid. I just put B for basic amino acid. That is kind of initiate the reaction. It's going to take off a hydrogen here. The hydrogen's going to leave these electrons, and this hydrogen here will leave to go to FAD+. Now when that happens, FADH here forms, it grabs the hydrogen, and the base forms a double bond. So here, both of those hydrogens are leaving. The base grabs this one. Hydrogen here leaves with FAD, and then here's the formation of the double bond. So that's it. Basically, something grabs this hydrogen leaves, it forms a double bond. So that's the next reaction. Now the one after this, let me get rid of all of this. So again, pretty simple. Again, we're just forming a double bond. Now we'll start with this structure that we just formed. CH double bond, CH, COO minus. Now this one, you've seen this reaction before. Oops, yes. Okay, now let's look at the difference between them. The COO minuses on both of those on the top and bottom stay the same. So the reaction is all right here. Now you see this double bond is gone, and we've added across here an H and an OH, which is just water. So we're adding hydrogen across a double bond. So first, the double bond grabs a hydrogen, leaves the electrons. So you'll get this, H2, CH positive, COO minus, and then your OH here will come in, add on to that carbocation, and form your final structure. So it's just the addition of water across a double bond, very simple. And then under this, we just have one more reaction, and this forms malate. So the last thing we need to do is oxidize this structure right here. Okay, so let's start with what we ended with. So we have COO minus, and then we have it's CH2, COHH, and COO minus. Okay, this is an OH right here. I'm not sure what that looks like. Now, NAD plus. This is a strong enough oxidizing agent, meaning it's going to add oxygens, take away hydrogens. For this reaction, NADH, and then also an H plus. And then let's see what the final structure is that happens here. CH2, C double bond O, C double bond O. So basically right here we form a carbonyl. So this OH is where your carbonyl will form, and we're going to lose an H and an H. And you can see here NAD plus takes away an H, and H plus is floating around. So basically all that happens, since this is a strong oxidizing agent, it allows the electrons here to pull down to form the double bond, to form this carbonyl. Let me use a different color actually. So these will come down here to form this double bond, okay? And which will cause this H here to leave with NAD+. Okay? Now right here you have this hydrogen that will be information, a base or whatever, will end up taking it off, or it'll just float off if it's in an acidic environment and give you this stable structure here. The most important part here is that you're just oxidizing this alcohol here into the carbonyl using NADH. So NAD plus and FADF are your strong oxidizing agents. This one's stronger. Okay, what does an oxidizing agent do? It will, well, one, it tends to add bonds to oxygen and takes away hydrogen. So all of these reactions here, the reason these are so important, you're forming, like NADH, FADH, these are important byproducts that you'll use in other reactions in your body. Then also forming these bonds and breaking them releases a lot of energy in your body. So the Krebs cycle is a way, basically we start with a sugar and we break it down into the body so you can have energy. It's basically how do we get energy from eating food or whatever. It's in the Krebs cycle. So I hope this helps and you at least get at least somewhat of a start for your biochemistry course.